Hello everyone, Anthony Sequeira here with StormwindLive.com and IPExpert.com, and in this particular supplement to our routing and switching lab fundamentals and written bootcamp, we're going to take a look at EtherChannel and its configuration the safe way. First, let's say that we are asked in the lab exam to configure an Ether channel between Fast Ethernet 23 and 24 on switch 1 and switch 2. And let's say we are not to use DTP, but we're to make sure there's one big 802.1q trunk link between these devices. Well, the first thing that we want to do is go into interface configuration mode for the two interfaces in question, and we want to make sure we configure the trunk parameters correctly. But I'll tell you, we really don't want any particular mismatches in anything, right? The trunking parameters, we especially don't want mismatches in the Ether channel negotiation protocols of either PAGP or LACP, so I just love to shut the interfaces. Absolutely, I love to shut the interfaces. As a matter of fact, there might be a case for defaulting the interfaces and then shutting them down to make sure that you have just clean configs to start with if we're building these Ether channeled trunk links from the ground up. Now that we're shut down over here, I will go ahead and issue my trunking related commands. Switch port, trunk, NCAP, .1q for instance, switch port mode trunk, switch port no negotiate. So we enter in our commands. Notice the shortcuts there. That's why I don't use aliases. But anyways, notice our commands are input to build the trunk the appropriate way that Cisco wants it built. Now we're ready for our Ether channel configuration. We might want to do show IP interface brief. What I'm doing here is I'm making sure there are no existing Ether channels built because I don't want to overwrite those. Yeah, watch out for that. Once I've confirmed that, I go ahead and I do my channel group command. We know there is a channel group number. Folks, this number is locally significant. That's it. It is a number of local significance. It does not need to match the other side. Let's prove that in this video. I'll go ahead and do this one as 10. Now, by the way, I would always match the other side. There's no good reason not to, but I just want to prove that it's a locally significant number. And then I'm going to choose my mode. Remember here, mode on is to statically configure the Ether channel. Mode desirable is the PAGP methodology. Mode auto is the PAGP methodology. And then active and passive are the possible LACP open standard methodologies. So read very carefully in your lab exam about exactly what mode you are supposed to do. Let me flip a coin for LACP versus PAGP. I need a three-headed coin. Actually, there's three options here: static, PAGP, or LACP. Let me just flip a coin and, oh yeah, we're doing LACP. And let's say that switch number 2 is the switch that is to initiate the LACP negotiation. So this side will be passive. We'll do a mode passive on this particular side. Notice we create our port channel 10. But look, nothing is operational yet, because the underlying physical interfaces are safely shut down. Now we're going to skip over to our other switch. That is switch 2. We're going to say interface range FA0/23 to 24. We're going to say no need to shut down here because the other side shut down, but we do need to do switch port trunk NCAP.1q switch port mode trunk, switch port no negotiate. Great. Now we'll do our channel group. I'll do 20 on this device, mode, not active. Which were they? Yes, mode active. See, I got a little confused there, but context sensitive help to the rescue. Gotta love it. All right, so this side is going to be the active LACP side. We hit enter. We then end. We do our save. We go over to switch number 1. And all we do over here is no shut. But let's think ahead of the device. Let's stay one step ahead of the device at all times. We think, what's going to happen after we enter this no shut? Well, I hope the underlying physical interfaces are going to come up. I hope the logical port channel interface will come up. That's what we should expect to see. So I hit carriage return on my no shut command, and we wait. Okay, there's the physical up. There's the data link layer up of the physical interfaces. And there's our port channel up. And we can see its layer 2 changed to up. Wow. We have just succeeded in our Ether channel configuration the safe and effective way. Believe me, you don't want a mismatch of the Ether channel negotiation protocols because it can be a nightmare to recover from that situation when time is ticking down on you in the lab exam. So that's the safe and effective way to build that Ether channel. Now, if you're into over-verification, if that's your thing, well, then certainly we can do our show, what would it be? Our show Ether channel commands, right? And we can do like show Ether channel detail, and we can get more verification this way. But for me, folks, just the simple way in which we built it very carefully and then got those status messages to come up really tells me that we're good. By the way, the show Ether channel detail is pretty terrible. Just regular old show Ether channel gives us some great verifications here, like that we are indeed using LACP, that we've got 2 ports in this particular bundle. And then another great command is show Ether channel summary. Really love this one. This one says, look, you got port channel 10, and it is currently a layer 2, and it is in use. You're running LACP, and oh yeah, by the way, it's the stars of the show, Fast Ethernet 0/23 and 24 that are in that bundle, and they are flagged with a P designation to indicate they are indeed bundled in that port channel. Folks, that's our key information about the configuration of Ether channel. It can be pesky unless you do it this safe method. Thanks so much for joining us, everyone.